discussing here is a problem that I encountered at work. It's going to be an AC switch. All right. So let's say we have an AC signal going into a device. We have a button that we press. And what the button is going to do, it's going to serve as a switch. So when we press the button, like when we press it, what that does is it will electrically connect this. And it's going to do that for 10 milliseconds. So it's going to be like this. So you press the button, and then it closes. And it only closes for 10 milliseconds. So on the output, it's just going to be like this. So here's the circuit to make an AC switch. So we have our AC input. We've got a NMOS transistor here, NMOS transistor here, a battery, resistor, battery resistor. And then this right here is what's called an optocoupler. This is not something that's like taught super well in school, but we'll go through what this is. So the way the circuits works is we have our AC voltage from here and here. When the voltage from the gate to source is 0, it's as if the load here is disconnected from the AC. But the minute we put a voltage from across the gate and source using this battery by electrically connecting this together, the minute we do that, the transistor switch turns on, and then the AC voltage is going to be transferred to the output. So the way we do that is with this optocoupler. So the way an optocoupler works is like this. Now we're going to have DC battery that you can switch on. So the minute we close this and get there to be a voltage across these two terminals, it's going to electrically connect these two. So if we were to connect this, it would connect this. That's the behavior of it. And the way it works in actuality is like this. So the internals, there's going to be a light emitting diode in there and a BJT transistor. And when we put a voltage across that diode, current is going to flow through this diode. So yeah, when we put voltage across this diode, current is going to flow through that diode, emitting light, which will then go into the base of the transistor. And with how this transistor is made, it's going to electrically connect this node to this node, thereby allowing current to flow. So that's what an optocoupler does this. And this is very valuable because it's much simpler to implement than a transistor switch, because you don't have to do any sort of calculations. You just put a battery across and then it just connects this and this. Component right here is the optocoupler. Right? So now let's go over some hazards. When you plug in your AC source, it's important that when you measure with your oscilloscope, that your oscilloscope is floating, like it's differential. And the reason why that is this ground cannot be the same as this ground. If you do that, you're going to get like a short circuit, because this AC is going to be trying to put a huge voltage polarity across two different grounds, and something will blow up. And you can damage your computer, because the Arduino is what's going to be like for this right here, this VDC is going to be controlled from an Arduino. Okay, so let's go through the code of it now. Okay, so this is the code for it all. All we have is well, I guess it's more too complicated to explain easily, because at least from the top of my head, because this is done with buttons. But the gist of what it does is this. So there's two buttons. Button 1, button 2. When you press button 1, the Arduino is going to output a longer pulse. It's going to be from 5 volts, 0 volts, 5 volts, 0 volts. And we'll call this time t. So the Arduino is going to send signals into here to electrically open and close it for time t. And we have two buttons. Second button does the same thing, except to me 0.1t, whatever we want to change it to. Okay, now that you've seen the schematic, let's do the demonstration of it all. This is the circuit. This is the transistor, first transistor, second transistor, These are the two optocouplers. Hold on. This right here. This and this is that and that. Hold on. Okay, so this and this is that and that. Those are the two optocouplers. These are the two transistors. We've got the resistors right there. So this and this is that and that. And then we've got a resistive load right here, which is right there, what we're putting our oscilloscope on. And then these two DC batteries right here. That. And our AC, this right there is coming from this machine right here. This machine is connected to the wall. So earth ground is connected to this. That's why you have to be careful with your microcontroller. Oh yeah, it's important that you see on my computer does not have the charger in it. Like this is just going in my iPad. And then over here it's just the wire to the camera. But I cannot plug in my charger into there. Because if I do that, I might damage my computer. Because there'll be a short circuit or something. Oh yeah. And this machine down here, what this machine does is to make our oscilloscope be differential, such that it can measure the voltage across any 2 points, not with respect to an earth ground. In order to convert this to be differential, you need this machine. And this makes measuring a lot safer. So you plug this machine in, and then you plug it into supply power to the oscilloscope. And now this oscilloscope is completely floating such that it's differential and there's no hazard when you measure. Okay. Let's press some buttons. So there's two buttons, one there and one there. The first button, this one, let me just upload the Arduino one more time. That's the first button. As you can see, switching on for yeah, right there. It quickly switches it on and off. Exactly as it should. If I press the second button, the trigger will back up. We'll do it for a different time. So yeah, right there. Yeah, there you go. That's how you make an AC switch using transistors and safely and high voltage. So, because this right here can easily be turned up to make it be 140 volts. And this circuit on the breadboard will be able to process all of that, and the oscilloscope will measure it. Yeah, that's how you do that.